Okay, so today we are going to do multiplying and dividing with scientific notation. And to multiply values in scientific notation, you're going to rearrange the multiplication problem and apply the laws of exponents. So for example, 4.5 times 10 to the 5th times 2 times 10 to the 3rd. So you are going to rearrange 4.5 times 2 and then 10 to the 5th times 10 to the 3rd. Therefore, your final answer in scientific notation, so you're going to multiply these two first, which is 4.5 times 2, which is 9. And then 10 to the 5th power times 10 to the 3rd power, which you're going to use your product rule and add your exponents. So 5 plus 3 is 8. So 9 times 10 to the 8th power. Let's do an example before we move on to dividing. So for multiplying your scientific notation, 3 times 10 to the 4th power times 7.2 times 10 to the 2nd power. So we're going to multiply 3 times 7.2 and then 10 to the 4th power times 10 to the 2nd power. Okay, so I'm going to first multiply 3 times 7.2 and I get 21.6 or 6/10 times 10 to the, and we're going to use our product rule to add our exponents. So we're going to get 10 to the 6th power. Now, I want you to look at this right here, this coefficient in the front. That is not correct scientific notation. Scientific notation is the first number has to be between 1 and 10. 21 is over 10. So we're going to move our decimal over one place. So that will make our number 2.16 times 10 to, and we have to add 1 here. So 10 to the 7th power. That is our answer. And to put that back in standard form, 216. So we have 1, 2, 3, 4, 5, 6, 7. I'm going to put my commas every 3, so it's 21,600,000. We'll do another example. So here's another example of multiplying. We are going to gather our coefficients, so 1.5 times 5, and then 10 to the 5th power times 10 to the 3rd power. And when I multiply 1.5 times 5, I get 7.5 times 10, and I'm going to use my product of powers rule and add my exponents. So 5 plus 3 is 8. So 7.5 times 10 to the 8th power. And when I look at it, this coefficient is between 1 and 10, so that's correct. To change it to standard form, 7.5, 1, 2, 3, 4, 5, 6, 7, 8. So 750 million. Okay, so now we're going to talk about division and dividing in scientific notation. To divide values in scientific notation, rearrange the division problem and apply the laws of exponents. So we are going to, for example, divide 8 times 10 to the 6th power divided by 4 times 10 to the 3rd power. So we're going to break this up into basically two division problems. 8 divided by 4, and then 10 to the 6th power divided by 10 to the 3rd power. So 8 divided by 4 is 2 times, and we're going to use our law of exponents to divide 10 to the 6th power divided by 10 to the 3rd power. And because we're dividing, we're going to subtract our exponents and keep our base. So our base is going to stay as 10. 6 minus 3 is 3, so our answer is 2 times 10 to the 3rd power. We're going to move on to some examples. So moving on, we're going to start with this example. 9 times 10 to the 9th power divided by 3 times 10 to the 7th power. So really, you probably don't even have to break this up and rewrite it. You could probably just draw a line. So 9 divided by 3, if you want to and you want to write it like this, you can. But really, this fraction bar or, fraction bar, you can, since it's already there, you don't even need to rewrite it. I'm just going to draw a line through it because I'm going to save time. So 9 divided by 3 is 3. And then 10 to the 9th power divided by 10 to the 7th power. Well, 9 minus 7, because just like we would for the quotient rule, you're going to keep your base. So times 10, our 10 is our base, and then subtract our exponent. So 9 minus 7, which is 2. And if you check, 3 is between 1 and 10, so it's appropriate scientific notation. So our answer is 3 times 10 to the 2nd power. And in standard form, that is 3, 1, 2. So 300. All right, next example. 9.45 times 10 to the 7th power divided by 2.1 times 10 to the 2nd power. So I'm going to again just draw a line so I know that it's two separate division problems. You have 9.45 divided by 2.1. So I'm going to plug that into my calculator. 0.45 divided by 2.1. I get 4.5 times, and remember, for our quotient rule, we keep our base. Our base is 10, and we are going to subtract your exponents. So 7 minus 2 is 5. 4.5 times 10 to the 5th power. Is this between 1 and, is our coefficient between 1 and 10? 4.5 is between 1 and 10. So we have correct scientific notation. And our standard form, 1, 2, 3, 4, 5. So we have 450,000. All right, for the back, we have a couple cases where we have one in scientific notation and the other numbers in standard form. So we are going to just do one of each, and then you can try the others on your own. So what I'm going to do is I'm actually going to put the number in standard form into scientific notation. You can change the other one. I think it might just be easier to put it in scientific notation. So I'm going to convert this number into scientific notation, and let's see. 1, 2, 3, 4, 5. So I have 1.2 times 10 to the negative fifth times 6 times 10 to the negative second. So remember, with multiplication, you're going to rearrange. So we have 1.2 times 6 has one problem, and then 10 to the negative fifth times 10 to the negative second. So 1.2 times 6 is 7.2, and times 10, so we're going to use our property product rule, and we're going to keep our base, which is 10, and then we're going to add our exponents and get negative 7. Negative 5 plus negative 2 is negative 7. And this is in between 1 and 10, so we have correct scientific notation. So 7.2 times 10 to the negative 7th. And what that looks like in standard form, we have 1, 2, 3, 4, 5, 6, 7. All right. I'm going to let you do that next example on your own, so you can pause it and try that example. Now I'm going to move on to the division. So again, I'm going to convert this number into scientific notation. So 1, 2, 3, 4, 5. So 6 times 10 to the negative third divided by 3 times 10 to the negative fifth. And just like I did on the front, I'm going to draw a line so I know I have two different problems, or two separate problems. 6 divided by 3 is 2 times, and we have to the negative third and negative fifth. We're going to keep our base, which is 10, and then negative 3 minus negative 5. So negative 3 minus negative 5. And remember, when you're subtracting a negative, it's like really like adding a positive. So we have 2. 2 times 10 to the second power. And this number, our coefficient, is between 1 and 10, so it's correct scientific notation. So 2 times 10 to the second power. And in standard notation, that is 1, 2. So 200. Okay, so I'm going to have you try number 8 on your own, and then also numbers 9 and 10. And if you need any help, make sure you ask.